Control flows can contain any or all of three broad kinds of elements. The first is tasks, and these are just steps that the package performs, including data flow, file management, and scripting abilities. There can also be containers. These containers let you build a package in units and provide looping and sequence operations. And then there are precedence constraints. These determine the order of operations, as well as allow flow to branch based on success, failure, or some other result of a task. Tasks in a control flow often require connection managers, which are a reference to external resources, such as the file system, an email server, or another program. You'll need to create a connection manager for each external resource that any control flow tasks need to access. The SQL Server Data Tools provides a designer for building control flows, much like creating visual forms such as windows and web forms. All right, let's talk a little bit more about each of those three kinds of components. First up is tasks. Tasks provide the primary functionality of a package in SQL Server Integration Services, and they're the foundation of a package's control flow. Each task in Integration Services is designed for a single purpose, which can be as simple as moving a file or as complex as importing data from web services and processing complex data flows. As a programmatic step in the package, each task performs its operation when invoked at runtime when you execute a package. A task is a discrete unit of work, and it performs many of the typical actions that an ETL solution requires. As you'll learn shortly, Integration Services comes with a large number of tasks built in, and you can even create your own fairly easily if you know how to write .NET code. You build packages visually in Data Tools by dragging tasks from the toolbox onto the Control Flow Designer. And there's an example of this. So in this case, I've dragged a data flow task onto the Control Flow Designer, and I'm also viewing the properties of that data flow task. So again, you first of all drag it onto the control flow surface, and then you set the properties and configure each task in the Data Tools Designer by using editors that the task type supplies. Once you place tasks in a control flow, you connect them to construct a logical, in-order flow of execution. The next component I'm going to talk about is containers. Containers provide grouping, looping, nesting, and other services to tasks. Conceptually, you can think of containers as specialized tasks, which allow for the special execution of child tasks, including grouping tasks together and iterating over tasks. The containers include a for loop, a for each loop, and sequence tasks. And using these, you can add a lot of flexibility and power to a package's design. This is where control flow has some similarity to a procedural programming language, but in this case, it's really a visual language. So, for example, say that you're building an integration services package that downloads a set of text files with data that you want to import into SQL Server. This figure shows a portion of this kind of package that downloads the files, then uses a sequence container to perform tasks in order, and a for each container to process each file in a specified folder. And it loads the data into a SQL Server table. By using containers this way, you can define what has to happen to each file only once, and the package repeats the steps for all the files in that folder. The folder could be empty or contain thousands of files, and the set of tasks will process them one by one by one. All right, next up is precedence constraints. Precedence constraints let you control the flow of your package by placing conditions on the routing of execution through your control flow. Visually, precedence constraints are the arrows that you drag from one task or container to another in a control flow, and which tie the execution of the first task or the container to the next. Depending on the success, failure, or user-specified expression on the constraint, control will pass to the task or container specified for each of these use cases by the precedence constraints. All right, so there's several different types of precedence constraints. An error constraint is red, success constraints are green, and a completion constraint is blue. And here shows an example of several tasks with precedence constraints. Again, the error constraint in the upper left is red, and it shows failure. So that means that if anything goes wrong with the execute SQL task, the data is going to flow along that failure path. And then there's some sort of file system task that's defined in order to handle that failure. And continuing on the left side, when that file system task completes, then there's an email that is sent, which is that task at the bottom of the figure. Otherwise, the other precedence constraints within the figure are success constraints. So when the execute SQL task executes successfully, it's going to send control to the data flow task as well as data flow task 1. So in this particular scenario, there's two different kinds of data flows that need to happen in response to the execute SQL task executing successfully. And then those two tasks in turn, once those execute successfully, in other words, if there's no errors, they'll also send an email. So you can start to see that by using the various types of precedence constraints, you can create complex control flows that allow for different paths when a task succeeds or fails. And you can use rich integration services expressions to create custom conditions to control the flow. This is probably one of the single most powerful features in integration services that let you handle complex data workflows. Now, you don't have to bind all tasks in a control flow together using precedence constraints. If the control flow has a task for which the order it executes relative to other tasks within the control flow, that order doesn't matter, then you don't have to constrain it with precedence constraints. When you execute the package, the integration services runtime engine will probably run sets of unrelated tasks in parallel in whatever manner it deems the most efficient for overall execution of that package. Once you add a task from the SSIS toolbox to the control flow designer, you almost always have to configure the task before it's usable. The designer makes sure that you know when a task isn't ready to execute by placing a red X icon in the task, and you can hover over the X to get the gist of what the problem is. Many tasks require that you create or designate a connection manager for use with the task, the name of an external package to execute, or you may need to write some scripting code for it to execute, or any of the many other possible details that are specific to any of the different kinds of integration services tasks. Sometimes you simply have to set a property or two, but other times you'll need to do some work to get the task ready to execute as part of the package. Most of the time, you'll need to spend some quality time with the task's Task Editor dialog box. You can open this dialog box either by double-clicking the task in the designer or right-clicking it and selecting Edit from the pop-up menu. Not all tasks have the Task Editor, but most do. And you'll find that the sets of properties and pages provided by each type of task editor is laid out consistently, often with a number of pages to keep its interface manageable. For example, this figure shows the Execute Process Task Editor dialog box. That's just one of many of the tasks that are available for a control flow. The General page lets you give the task a meaningful name, which you might change to something like Open Notepad, if the task, in fact, opened Notepad. And you can add a meaningful description as well. You should always give tasks meaningful names and descriptions so that entries and error logs can quickly lead you to the task that's causing a particular problem. It's a very important part of troubleshooting. The Execute Process task runs Windows executables. So the Process page, which I show here, is where all the meaningful configuration for this task happens. Here you can set the name and location of the executable that should execute when this task within the package executes, as well as set arguments to pass to it, set a timeout value, and define the window style, which can be normal, maximized, minimized, as well as hidden. So as you can see, these properties are very specific to this type of task, executing a Windows process. One of the ways that integration services let you build flexible and powerful packages is by letting you define expressions that dynamically set the value for a task's properties. You can access this ability on the Expressions page of the Task Editor dialog box. Pretty much all of the Task Editor dialog boxes have this page for all the different tasks within a control flow, because it lets you specify a task property that you want to set dynamically and let you define the expression that generates a value for that property. An expression can be a constant value, in which case you may as well set the property directly using the task editor, but you can set a constant value if you really want to. Or it can be an expression or a variable, which itself can either have a constant or an expression. So you could read values from a configuration file or calculate property values just about any way you want. It's another way that integration services packages are extremely flexible. All right, let's talk a little bit more about what control flow tasks are available. In a typical package, you'll spend most of your time working with tasks, adding them to a package, configuring them, and ordering them with precedence constraints. Control flow tasks in integration services are the executable instructions within a package. Again, using that analogy to an executable that you create using a programming language. Integration services includes a few dozen stock tasks, plus containers, and developers can create additional control flow tasks to install in the integration services environment. A large part of the work in understanding integration services is learning which tasks are available and how to use them. There's some overlap in what individual tasks can do, but for the most part, each provides a specific set of functionality to support the overall mission of a package. To make sense of the rich variety of available tasks, I group them into several different categories. The first category of tasks is workflow tasks. These include tasks that execute other packages, execute other programs, communicate via email, and gather information from the operating system. And here's some of the workflow tasks. The first one is the execute SQL task. It runs one or more SQL statements or stored procedures, including any mix of data manipulation language, which is DML, or data definition language, which is DDL, which means that you can both modify data as well as modify the schema or the structure of your database and its objects. And these work on any database that supports SQL, like Oracle or Access, and of course, SQL Server. This is a Microsoft product after all. There's a variation on Execute SQL called Execute T-SQL Statement Task. This also executes statements on specific objects, but it's limited to a SQL Server database. And you're also limited here to SQL Server's variant of SQL, which of course is Transact SQL or T-SQL. The Execute SQL task is able to pass through SQL that is specific to the backend data store. Then there's the Execute Package task. This executes another integration services package. And this is a great way to modularize packages so that none of them become too large or too complex or too hard to maintain. And then there's an Execute Process task. I've already talked a little bit about this one, but this lets you execute a process outside of it integration services. So you can run Windows programs or components or whatever you might want to execute within the Windows environment. Then there's a Send Mail task. As the name kind of implies, it sends an email. And this can be really handy to send notifications of package execution or when there's a problem. Next up is the FTP task. And this uploads or downloads files using FTP. This is often a first step in a package that processes text files to import data into a database table. You have to download them from some remote location. But you can also use integration services to create different kinds of flat files, say, and then upload those flat files using the FTP task to some remote location. File system task performs various operations on folders and files in the file system. So you can do things like create folders and move files. There's a WMI data reader task. WMI stands for Windows Management Instrumentation. And this data reader uses the WMI query language to find information about the host Windows operating system, through items like the event logs and other system resources. It really provides a very deep access into the internal workings of Windows. And then there's the WMI Event Watcher task. This watches for events on Windows using the WMI query language. And this does tasks like starting processes once other processes are completed, or deleting files after a data load is completed. So you're generally going to use this with the WMI Data Reader task. And then the last one is the Message Queue task. This sends and retrieves messages to and from the Windows message queue. This lets you use a package to coordinate multiple operations throughout an enterprise. The next category of tasks is data processing tasks. This includes tasks that read or write data from various sources and work with XML data. And here are some examples of those. The first one is the one that you'll be using a lot. It's the data flow task. This is the main workhorse of most integration services packages. It uses the integration services data flow engine at runtime in order to move data from its sources through in-memory buffers and manipulates it with transformations before loading the data into a destination, some final resting place for that data. The data profiling task profiles data, analyze source data, and to prevent data quality problems from making their way into the destination store. The bulk insert task lets you fast load data from text files into tables or views in SQL Server by using the TransactSQL bulk insert command. The XML task is very handy because it lets you use integration services to load XML documents from files and perform a range of operations on that XML data, doing things like validating it against a schema, applying extensible style sheet language transformations, or XSLT, and comparing documents. And then finally, there's a web service task, which lets you execute a web service method, which usually means that you want to access or get some kind of source of data from a web service on a web server someplace. Okay, next up is the scripting category of tasks. This includes tasks that execute scripting code. Essentially, you can write your own common code. Now, two examples of this are ActiveX Script and Script. First, I want to talk about the script task. This executes custom VisualBasic.NET or C# code that you write. The idea here is that when no other task fits your needs, you can use this task to customize a control flow, do things that you can't otherwise do with the built-in task. Now, the one downside to this task is that it's not reusable across packages, but there are other ways to write reusable code. Now, this ActiveX script. Earlier versions of integration services also had an ActiveX script task that was a holdover from Data Transformation Services, or DTS, of the SQL Server 2000 era. It let you write VB script code within a package. Microsoft for years carried this task forward into integration services in order to provide a measure of backwards compatibility with DTS, but thankfully finally dropped it in SQL Server 2012. So it's no longer available as long as you're using integration services in SQL Server 2012 or SQL Server 2014. But the good news here is that the script task, the remaining script task, is powerful and much easier to use than the ActiveX script task ever was. All right, next up are SQL Server tasks. This includes tasks that directly access or modify SQL Server objects and data. So as you can see, these are pretty much all transfer tasks for moving objects from one location to another. So you can transfer a database that transfers an entire database using server management objects. Transfer jobs transfers SQL agent jobs from one server instance to another. Transfer logins lets you copy logins. I'll talk about the transfer SQL Server objects in just a second. And then there's the transfer master stored procedures task. This transfers user-created stored procedures from the master database of one server to the master database of another server. And then the transfer error messages task transfers error messages from one server instance to another. Now let's go back to the transfer SQL Server objects. As you can tell from all of the other tasks, they're fairly specific. They transfer a particular kind of object. But the Transfer SQL Server Objects task executes T-SQL statements that's more granular in operation than the transfer task, the other transfer tasks, for specific kinds of objects. So you're able to write your own Transact SQL code in order to move objects using this more generic Transfer SQL Server Objects. So in general, you should use the more specific task if it's available, but if you can't do what you need to do with the specific task, use the more generic Transfer SQL Server Objects task. Then there are a set of analysis services tasks, and these include tasks that directly access or modify analysis server objects. So the analysis services execute DDL task runs a multi-dimensional expression, or MDX query, that creates objects for an analysis services queue. And you can use it to deploy an entire analysis services database. And then there's analysis services processing task. This processes objects on an analysis services OLAP queue. And then the data mining query task performs a data mining query on an analysis services OLAP queue. So even though there's only 3 tasks here, there's very powerful things that you can do with these 3 tasks. And then there's some maintenance tasks. These include tasks that perform SQL Server maintenance functions, doing things like backup, reindexing, and running SQL agent jobs. So as you can see from this set of tasks, you can use integration services packages to perform a lot of different kinds of maintenance tasks. So the backup database task executes a backup on a specific SQL Server database. It can be a good idea to save the target database before your package makes changes to it. Then the check database integrity task runs an integrity check on all of the objects in one or more SQL Server databases and then reports back to you the results of that check. You can also execute SQL Server agent jobs. And you can also clean up history. And this cleans up the backup and restore history that's contained in the MSDB system database on a SQL Server instance. There's also a maintenance cleanup task, which removes old maintenance plan items created by maintenance plans, things like text file reports. There's a notify operator task, which sends a message to SQL Server agent operators outside of the Transact SQL or DBCC utility structure. The rebuild index task rebuilds an index or a number of indexes in one or more SQL Server databases. You can also reorganize indexes. And then you can use the shrink database task to shrink an entire SQL Server database to specifications that you set in the properties of that task. And then finally, there's an update statistics task. This runs the SP update stats system stored procedure. Now, the thing about this categorization is that not all tasks fit neatly into a single category. So, as you can see on the figure here, the execute SQL task could be a data processing task or a workflow task, because you can use it not only to access data in a SQL Server table, but also to prepare a table for bulk insert. Nevertheless, all of these categories that I've talked about are useful for learning the scope and breadth of tasks that are available within integration services.